Everyone, thanks for the invite. Yeah, we will be talking about one of the topics that kind of part of my passion, because I started as a Java developer in the end of the last century, which reveals how old I am. Basically, yeah, I'm working for the company called IP Labs. We are doing a lot of things with AWS Serverless. We are completely on AWS. Not so much in the serverless Java space, but this is kind of the topic of my private research and articles published a lot. We have small applications with serverless, but basically because of the things we are missing as we started 6 years ago, we needed just do things differently. But now you have choice to reconsider. Yeah, if you're just starting the journey. Yeah, I'm one of the AWS community builders, organizer of Java user group Prawn, so kind of this stuff. Now let's start generally Java popularity. Really cool programming language, huge community, lots of open source projects, Spring, Quarkus, or whatever. And Java is, I would say, among the top 3 popular programming languages in general, depending on the statistic, GitHub projects, job postings, Stack Overflow questions, however you can calculate that. But if you will show into how many Lambda functions are written in Java, and you see on the left side the kind of survey 3 years ago, on the right side the survey last year, it's still top 3, but the results are 10%, and this is kind of very, very frustrating. That has reasons. Basically, this call starts and memory footprint are just the problems that we have. Not for every application is call start a method. It's completely asynchronous, that's fine, but there are lots of synchronous web API REST applications where it matters, and we will see the results. So basically, everybody should know what call start is. It's AWS conference. If I'm on Java conference, I explain it, but let's assume you know this, and we'll just show some basic application that I wrote just to showcase, create products, delete products, update products. By idea stored in the DynamoDB, I will be talking, there was a great talk before that, using Aurora, or I will do some references because the numbers will be different, but basically the starting point is to give Lambda 1 GB of memory, which is a big one, but that's one of the kind of the standard cases. We'll use default HTTP client. If you're talking to DynamoDB HTTP based, this application has 18 megabytes artifact size. There's some compilation options that are better suited, and I just simply did a stress test for 1 hour, pushing lots of requests and pausing, pushing then another bunch of requests. And in this 1 hour, I experienced 100 call starts and 100,000 work starts. It's my pattern. Your pattern might be different, but you see the number of call starts 1%, even low. It might be 2 or 3%. You can have spikes, so it's a different story. But basically, yeah, even 1%, if you will have 1% of the call starts, it also matters. So if you now do the metrics, yeah, what you will see from you see below this worm image, Java is a quick programming language. If you look, I just always try to see P90 because it's kind of okay. Yeah, 90% of the requests are that quick or even quicker, and you see 7 milliseconds. Worm starts are okay. We have max value. This is the outline. I will explain it. But if you look into the call starts, these are quite significant values. And this is a poor Java, so no frameworks involved, that Spring and so on, they can increase that even. But basically, you see 3 seconds, and if it happens in 1% of the cases, it might bite you because it's only Java call start. If you are talking through API gateway, you have latency of API gateway and all that stuff. You need to add this up. Yeah, and you also have client talking to Dynamo to API gateway. You just also time to establish a connection and all the stuff read the response. So the real number can be that just the whole latency can be 5 seconds, and in 1% of the cases it might bite you. So now let's look into the options how to reduce that stuff, because they are not for free in sense of you need to do this stuff. But there are. So let's start with the AWS Prawn offering, which came, I think, nearly 2 years ago. SnapStart, also AWS Lambda SnapStart. Basically, I'm about now the part 23 of my article series about this, because I look in all possible corners if there is something that you can reduce the call start or not. but I will show you things that really, from my experience, matters. So basically, Lambda SnapStart is the way to improve startup performance, call start times, and it's fully managed. What does it mean it's fully managed? Basically, it's your decision on per Lambda function to activate it or not. And it's basically a checkbox. You need to provide the version, but basically, I would like to use SnapStart or not. That's not more. And it's currently, the name is SnapStart without Java, but it's currently available only for Java runtime. So you cannot do it for other net programming languages, C# all that stuff. You can also do it for Docker container images deployed on Lambda and also kind of on custom runtime, but we will look into GraalVM there. So it's currently for Java technology, of course, for Python and JavaScript, maybe even doesn't matter because the call start don't bite you. So how does SnapStart work? It divides kind of, if you enable Lambda function for SnapStart for your Lambda function, then the life cycle of the function or the things that will be done are spread between the deployment phase and the invocation phase. And you see in the deployment phase, if Lambda function is enabled, AWS will invoke that kind of run through the call start phase of the Lambda function. So it will spin the environment and it will initialize the static block. It will not call the handler, the function itself, but only the static initializer block. So it goes through all call start phases, kind of, and then it creates a snapshot. The snapshot is the Firecracker microVM where Lambda is running. The whole operating system will be snapshot. There are optional hooks. We will be looking into that. And this is during the deployment phase. So it's not the live phase of the application. So it prolongs the deployment phase, extends it. And then the invocation phase, in case you enable SnapStart, the snapshot will be restored as a first step. Yeah. So what's the logic or what's the promise? That the restore phase of the snapshot will be quicker than the call start. Otherwise, it just doesn't matter. You can have the normal call start. And we will be looking into that stuff. Is it true or not? So there is other things. So you see here these snapshots. Before hooks, before snapshot is created and after the snapshot is initialized. So you can use it to pre-warm things. So the goal is to put as much as possible into the snapshot so that it's kind of then the restore phase just don't need to deal with the initialization. So what you can put additionally, because initializing the static initializer or going through the static initializer block is not the whole story. The business logic might be in the Lambda itself. And in case you are talking to HTTP-based service like DynamoDB, but it can be also SNS, SQS, so many services are basically HTTP-based. What you can do, and it requires knowledge how Java works or how this connection establishment works. So if you talk to DynamoDB, this is the example, kind of what the logic I put there. It's get product by ID. You will have something just establish DynamoDB client and talk to DynamoDB. When you establish the client or instantiate the client, the default one is Apache, but it takes time to instantiate HTTP client in Java because all these clients are written for long-running application like web service. So they add some several hundred millisecond one time per life cycle. That's okay for long-running application, not so okay for Lambda function because it just adds up to the call start or the warm start. Another thing is if you talk to DynamoDB, DynamoDB stores JSON, we have Java object. Once again, you need to marshal from Java to JSON or back, depending if you're writing or reading. Instantiation of this Jackson, or in case this is the Jackson marshal, but can be some different JSON library, also takes several hundred milliseconds. Also one-time operation, the life cycle. So if you can warm up the things before snapshot is created and put it into the snapshot, you can win things. And this technique is called priming. You prime things, you pre-initialize things. That, of course, involves a bit of more writing code, but basically I have anyway this get product by ID method in my code. And this SnapStart enables you to write these hooks. Yeah, and these hooks are CRaC API. It doesn't deal with CRaC itself. It's another technology, but it's only CRaC API, implement resource interface, and it gives me basically before checkpoint method for writing the logic to be called before snapshot is created and after restore, where I don't put things, but you see in this before checkpoint, I simply invoking get product by ID with ID 0. I'm not interested in the results. I'm interested in the pre-warming HTTP client. I'm interested in the pre-warming JSON marshal. And then the things will be put into the snapshot. So this, once again, it's priming. It might be if you are doing something like mathematical calculation, but you don't have anything to prime. So it's simply looking to your application. Maybe you can use SnapStart, but there is nothing that can be really prime. So once again, I will be showing you metrics. Yeah, SnapStart supports only Java. Deployment with SnapStart enabled takes between 2 and 2.5 additional minutes, because snapshots need to be created, encrypted, put in all availability zones of the region. It takes time. Yeah. If you have multiple Lambda functions, then the snapshot will be created in parallel, so not too much additional stuff, but only having that costs you time. So nothing is for free. SnapStart currently doesn't support provision concurrency. It supports ARM architecture, will be put into the metrics, and you cannot use AFS, NFS-based system. You can use S3. Yeah, so there are some limitations. Now let's look into the results. So this is kind of, I measured the performance with that logic that I showed you, that application. And you see, I already showed you the results without SnapStart enabled on the left. You see in the middle, the SnapStart enabled, but without priming, simply checkboxing. You see nearly 40–50% of the call start is gone only by that. By doing the additional priming, DynamoDB request priming, I can, if you see, I can go down to 1 second call start for P90. So from 3.5 to 1 second. Yeah, by doing that stuff, and it's a bit more logic to write, but it's significant. Of course, you don't get the results that you will get with Rust, JavaScript, and all that stuff. They will be lower. They will be even lower than half of the second, but it's nevertheless significant. These are the warm start things. Basically, SnapStart is technology for reducing the cold start. So for P99, you see really no real results. But what will be interesting is that the max value with priming is totally low, because in my initial thing, I didn't do priming. And now I primed everything. And if I don't do priming, then the first invocation, the warm start, can take time, because HTTP client and JSON will be then instantiated in the warm start phase. That's why this outlier with max value even for warm start. But with doing priming, I already instantiated this, so even max values are getting lower. So what I show you in several metrics, you can try out, of course, compilation options, but you can go also with the default of what I showed you. The same, you can try out different memory settings, because by assigning more memory, you assign also more CPU, so the function can be quicker or double as quick for the same price. This is what was always interesting. Okay, we know that deployment size matters, because the more code needs to be downloaded from S3, the more code needs to be instantiated. But what's for the case if you have SnapStart? Is you see the yellow one or the green one, so the artifact size matters still also with SnapStart. It's the difference is not that huge, but anyway, if you have a bigger application, also even if you use SnapStart and you use priming, you will be having bigger call starts anyway. So the things still matter. Use only what you really need. To package only things that you really need. In the long running application, we package too much because it just doesn't matter. But for Lambdas, just only what you really need. So no unit tests. They can have scope tests and all that. So I did some new tests that I'm currently writing about. For example, what's about using Lambda layers? You can use Lambda layer just to package something that neither all Lambda functions will have the same dependencies. Yeah, there is a possibility to publish them as a Lambda layer once, and then simply use the Lambda layer in the function that will reduce the package size of the application, and then the deployment might be a bit quicker. And I just wanted to figure out what does it mean for the call starts, especially, and what I figured out using the Lambda layer increases the call start. Unfortunately, because the Lambda layer needs to be mounted, and that costs a bit of time, less time if you use prime. You see the difference is not that big, but if you cannot prime or you don't want to use SnapStart at all, then be careful using layers that can even increase significantly. So there are other options you can explore. HTTP client. So once again, if you instantiate the DynamoDB client, you don't need even to pass HTTP client. It's by default there, and by default it's Apache. That's what AWS will do for you. There are other options. You can set it explicitly. There is the URL connection, HTTP client, and there is AWS own natively written in C, AWS CRT HTTP client. Of course, you need to include this dependency, but there are things in AWS own AWS CRT HTTP client is written for the kind of serverless world for short-living Lambda function. Also wanted to explore what's the difference. Yeah, and you see this yellow one that from AWS is really performing really good, especially with the priming, because I already pre-warmed the HTTP client. It just, the difference is not there, but if you cannot use priming, then it's really cool stuff. So if you don't use DynamoDB, but you would like to talk to some third-party service outside of AWS, you will need to have probably HTTP client. You can use directly this AWS own one. It just gives much better performance. Yeah, but with priming, as I already primed that, then the difference is logically not there. Yeah, if AWS gives some recommendations what HTTP client to use, so figure that out. There are some differences because the Apache HTTP client has so many options, and this from AWS on the reduced number, but it's sometimes I use default and it just doesn't matter. So what was interesting, AWS started with SnapStart only with x86 architecture, and 2 months ago they added also the support of ARM architecture when using SnapStart. So what's the deal? ARM architecture is Graviton-based, they are 25% cheaper. So the question I ask myself, if I now test that ARM architecture, what will it bring me? I did that, and you see this, the green one is ARM, and the red one is x86. For that use case, it may be different. The call starts are bigger with ARM architecture. You see that's P90 between 8 and 24%. So 25% cheaper, but 25% slower. But that's the cold start. The warm starts are better. Yeah, so only up to 10% slower with ARM architecture. So basically, it's now up to you just to figure out. You can give more memory, and then maybe 10% more memory, and you will have comparable results between them. But then you will pay maybe 10% more because of 10% memory. But ARM architecture is 25% more cheaper. So there is a use case, and I think the difference is not huge. But if you will find the right memory settings, you can save maybe 10-15% ARM architecture. And Java is right everywhere, so you can write the code everywhere you want, and then simply execute it on the Graviton Lambda. So you just don't need to write the code some Graviton architecture. So it changes nothing. It's only configuration, what architecture you would like to use. So I will jump over. So I will probably tell some words. I showed you the cold starts from the first 100 invocations after I changed the Lambda function. So I basically redeployed. What's cool is I tested that, and the first several invocations, which are counted here just to calculate the speed, all the percentiles were slower. So after the 6-7 invocation, I saw the cold start with SnapStart were weaker. I just investigated this and talked to AWS people that they explain me, and they explain me there is the tiered cache to store the snapshot. And this tiered cache is designed but that way that it stores pieces. It's like Docker layers. They're completely different pieces. And with kind of more execution until a certain level, it becomes quicker. And that's why if I will only show you the last 50 call starts and not right from the beginning after I redeploy the function, the values will be even better by 100 milliseconds. Yeah, I just wanted to show you the whole picture, and sometimes what does it mean to have 10 bigger call starts if your Lambda function will have maybe in the life cycle much more execution. So this is also kind of cool thing. I also wrote an article about that, but I personally, yes, so this is the results. If I want to show you the last 50, on the right side, it's the call starts going down, and this is kind of also cool stuff. But I encourage you to watch the talk by Mike Danilo, who is working the Lambda team. He explained in this QCon talk exactly how Lambda works under the hood and how this tiered cache works. It's really cool stuff. If you think of Lambda function, you can deploy the Lambda function, which will be there without any changes for years. But AWS needs to fetch Firecracker VM beyond the scenes, and they need to fetch Java virtual machine. So the same Lambda function for the whole lifecycle will be executed on the different environment. Yeah, it's not static, even if the code doesn't change. And it's really cool how they designed this cache so that they don't revalidate the cache completely, only because they patch the operating system. They invalidate only pieces of that cache because the code is stable. Yeah, and that's why they don't need to empty the cache. And with empty tiered cache, we will have bigger cold starts with SnapStart. So it's really, this is where the AWS shines, solving really hard architectural and technical problems. Yeah? So one more option, GraalVM, probably people in the Java space know it. Technology comes from Oracle Labs, but basically so many purposes. But the important stuff is gives us the GraalVM compiler, which basically gives us an option to deploy something as a ahead-of-time compilation. We can do ahead-of-time compilation, deploy native image of that stuff. GraalVM supports all kinds of native images, also Windows 1, but it's a closed work. You need to package everything that will be required during the runtime of the application, all the classes, because yeah, ahead-of-time compilation. Yeah, and the promise is, of course, because it's native executable, so no Java is basically involved, and the things are, of course, quicker and less cold starts. The question is how to deploy that stuff on AWS, because AWS doesn't support managed GraalVM. It's another virtual machine. It's not Java. It's parallel technology, but there is custom runtime. With the custom runtime, you can deploy native image or many other things, and it's basically you deploy the zip of the function. And there should be the bootstrap file, and bootstrap files in the case of GraalVM native image. Yeah, and basically with custom runtime you can do that. And now you see all the metrics. I measured the same application with the GraalVM native image, and you see on the right side, yeah, GraalVM native image provides the best cold starts. Yeah, that's half of the second, and yeah, that's how it is. And even the warm starts with GraalVM are less because native image, so no Java overhead kind of this interpretation of bytecode involved. So yeah, this again, P90 values, max values, so GraalVM provides best possible code starts. But of course, yeah, really powerful technology without any questions. But GraalVM, AWS custom runtime supports only Linux, so you need to build the native image on Linux, and it also takes 2 and 2.5 minutes to build for such an application native image. So the same with the SnapStart. This is developer experience suffers, and probably locally you won't do this. But the thing is, it requires you manage this stuff, and it requires 6 to 10 gigabytes of memory to build native image, and this is on your shoulders. This CI/CD stuff. Yeah, or the cost. You can use managed service that will scale, because sometimes you need to build several native images in parallel, and that needs to be scaled. Yeah, 6 until 10 gigabytes of memory. That's not very easy just to do it on some local environment. Probably you will have costs with that. Yeah, and this is something that it's significant. Yeah, I wrote also some other articles here about serverless, Aurora Serverless V2, how you can use that if you don't like DynamoDB. I also wrote now if you would like to use Spring Boot, many applications using Spring Boot and all that things. So my personal suggestion, yeah, these are both valid technologies to start with, yeah, that reduce the cold start significantly. In the case of GraalVM, it's also warm start. If you're willing to accept a bit higher cold starts, I would prefer to start with AWS SnapStart. It's managed as a checkbox. Yeah, if you would like to shave the millisecond possible, then do it with GraalVM, but then you need to scale the stuff. You need to think about the dependencies, because if the dependencies use runtime instantiation, then it will break the code, and sometimes you don't control all your dependencies in Java code. You just use some open source project and then brings a bunch of dependencies that can have some runtime stuff. There are things you can use some kind of reflection JSON and put all the files that will be instantiated on runtime, but you always need to adjust the stuff. So there's a bit more work involved with GraalVM anyway. So I personally really like this managed stuff. So there is Project Layton ongoing on Oracle side itself, that the goal is also just to improve the startup of Java application anyway. I personally not quite sure how it will fit into Java or into Lambda lifecycle model. There are first increments released by Oracle 7 months ago. They can improve kind of the cold start now by 50%. We'll see how it will be going, but with SnapStart you can improve it to that now. Yeah, so that I'm really curious how it will work and how you can do it in Lambda and what will, because SnapStart is really fully managed, and that's the beauty of that. Remeasure it, yeah, for your use case, because once again, I measured it with some certain Java Corretto minor version. If you will measure now the same code, there will be another version. Or AWS updated this. They updated also Firecracker, and they can improve snapshot creation store anyway beyond the scene. So you might have the same, and I put all the links on GitHub to the projects that I used for testing. You might have a bit different results, hopefully better results, because SnapStart is improved and you benefit from it automatically. And that's basically it. I hope you took something from that you can try out, because I really like Java, but of course don't expect the Rust papers. Yeah, that's not the goal. But the productivity of developers is also important, and I think you will, if you are in Java, learn a new language without all that stuff, how to create PDF in Rust, I don't know. Are there any open source projects or not? Should I write it on my own? I don't have time for this personally. So this is kind of the things that we always debate. And yes, Lambda is behind the scenes also written with Java and Rust on the AWS side itself, so they value both. Yeah, that's it from my side.